Now that we have learned how to evaluate a definite integral using the fundamental theorem of calculus, we can talk about average value. So when we discuss average value, we talk about the average value of a continuous function over a closed interval a comma b. And the average value is given as follows. It will be 1 over b minus a times the definite integral from a to b of f of x dx. So we want to find the average value of f of x is equal to 6x squared minus 2x over the interval negative 2 comma 3. So let's plug it into the formula. So that's going to be a is equal to negative 2 and b is equal to 3. So I'm going to have 1 over 3 minus a negative 2. Be careful with those double negatives. The integral from negative 2 to 3 of my function 6x squared minus 2x dx. Let's clean up the front. So 1 over 3 minus minus 2 will become a positive 5. And then I'm going to evaluate the integral by using the power rule and finding the antiderivative. So I'm going to add 1 to the power, which will become a 3, and divide by the new power. Minus 2x, add 1 to the power, divide by the new power, from negative 2 to 3. Now before I evaluate and use the fundamental theorem of calculus, I like to clean up my antiderivative. So this is going to give me 2x cubed minus x squared from negative 2 to 3. And now I plug in. I use the fundamental theorem of calculus. So first I'll plug in 3. So I'm going to have 2 times 3 cubed minus 3 squared minus 2 times negative 2 cubed minus negative 2 squared. And then you evaluate all of this. So this right here is going to give us 45 minus this right here is going to give us a negative 20, 1/5 in the front. So I'm going to have 1/5 times 65. It's going to give me 13. So the average value of f of x over this interval is 13. This is the average value of the output of f of x. Okay, let's take a look at some word problems. The total cost in dollars of printing X dictionaries is given by the following cost function. Find the average cost per unit if 1,000 dictionaries are produced. So this is old material. If you want to find average cost, which we denote by putting a line over C of x, this is a cost function divided by how many units you are producing, how many units you're looking at. So if we're looking at 1,000, this is C, the total cost of producing 1,000 units, divided by 1,000 units. So when I plug this in, it's going to give me 20,000 plus 10 times 1,000 divided by 1,000. So this is going to be 10,000 plus 20,000 will give me 30,000 divided by 1,000, which will give me 30. So the average cost per unit is $30. Now part B. Find the average value of the cost function over the interval 0 to 1,000. So now you have to use the integral, right? Make sure you understand how here the questions are worded differently from A to B. That's the trick. Here, first ask average cost per unit, and the second one asks to find the average value of the whole function. So I'm going to use the formula 1 over 1,000 minus 0 of the integral 0 to 1,000 of my function, which is 20,000 plus 10x dx. So in the front, I'll have 1 over 1,000. I'll take my antiderivative, which will give me 20,000 x plus 10x squared over 2 from 0 to 1,000. So this right here will become 5x squared. And then I'm going to plug in 1,000 and 0 by the fundamental theorem of calculus. So when I plug in 1,000, I'll get 20,000 times 1,000 plus 5 times 1,000 squared minus, and then I'll have 0 plus 0 because both of them have an x. So this is going to go to 0. So what am I going to have? I'm going to have equal to 1,000, 1 over 1,000 times, and then 20,000 times 1,000 will be 200,000, and then you can add that to 5 times 1,000 squared. And then when you divide by 1,000, this is going to give you, let's write it all out here, $25,000. Okay, so then part C asks, discuss the difference between part A and part B, right? Because they almost seem like the same, but they're actually not. So part A is the average cost per dictionary. So when you are making 1,000 dictionary, it costs about $30 to make each dictionary. That's per dictionary. Part B is the average value of the total cost. So it's the average value of the total cost, not per anymore. Now you're looking at the total cost, the average of the total cost when you go from 0 to 1,000 dictionaries. So for example, C of 1 would be the total cost of making 1 dictionary. C of 2 would be the total cost of making 2 dictionaries. C of 3 would be the total cost of making 3 dictionaries. And then finally, C of 1,000 would be the total cost of making 1,000 dictionaries, and you're looking at the average value of that number, while part A was just the average cost per dictionary. Let's do one more word problem. Record indicates that T months after the beginning of the year, the price in bacon of supermarkets was given by the following function, dollars per pound. What was the average price of bacon during the first 6 months of the year? Okay, so I have a function for price. My T is in months, and I want to find the average price of bacon during the first 6 months. So I have to use the integral formula. So I'm going to have 1 over b minus a to the b of p of t dt. And the first 6 months means you're looking from 0 to 6 months. So I have 1 over 6 minus 0, 0 to 6 of 0.06 t squared minus 0.2 t plus 6 dt. And now you have to clean this up, so 1 over 6, and take the antiderivative. So I'm going to have 0.06 t, add 1 to the power, divide by the new power, minus 0.2 t, add 1 to the power, divide by the new power, and the antiderivative of 6 is 6t. And I'm doing that from 0 to 6. So I'm going to have 1/6, 0.02 t cubed minus 0.1 t plus 6t from 0 to 6. So when I apply the fundamental theorem of calculus, I'm going to have 0.026 cubed minus 0.16 squared. Oop, I forgot the squared here when I simplified. Plus 6 times 6 minus, so that's the first part here, minus, and now I need to plug in 0, but because every single one of them has a t in it, when I plug in 0, the whole second part will go to 0. So now you can input this into your calculator, and when you do that, you will get that the average price of bacon during the first 6 months was $6.12. And here is our final answer.